And hello guys, my name is John Michael Reyes and I'm back for the chapter 7 tutorial and activities for the and chapter 7 is called IP addressing. IP addressing is critical function of network layer protocols. Addressing enables data communication between hosts regardless of whether the hosts are on the same network or on different networks. Both Internet Protocol version 4 and IPv6 provides hierarchical addressing for packets that carry data. Designing, implementing, and managing an effective IP addressing plan ensures the network can operate effectively and efficiently. The chapter examines the details in the structure of IP address and their application to the construction and testing of IP network and subnetwork. Somewhat, this is just about IP addressing on how we're gonna get the IP address, the network address, and other stuff. So let's proceed. And we're back, guys, and as you can see here, first we're gonna learn about the binary to decimal conversion. It converts the binary IP. As you can see, these are the position values, binary number, and calculate. First, always know that it is 1, 2, 4, 8, 16, 32, 64, and 128, then 256 and other stuff. But at first, it's just like that. Then it is somewhat very easy because you'll just, if there's 1, you will gonna count that, and if it's 0, you won't count that. So let's proceed. Then as you can see in here, 128 is up, 16 is up, 8 is up, 4 is up, and 2. The 2, 4, 8, it will be 14, then 30, 158. That's 158. Then let's check. As you can see, our answer is correct, and that is pretty easy. Then let's proceed to another activity. And in this activity, we'll just gonna we're just gonna apply the 1 or zeros in the binary. So it would be 162 minus 128. That would be 1 because 162 can be minus to 128. Then it would be 0 in 64. Then 32 plus 128. It would be, yes, it would be 1 because 32 plus 128 is 160. Then this would be 0, 0, 0, and 1 because then 0. Then as you can see, all my answers are correct because it's pretty much obvious and basic. So we're gonna proceed to the another video that we're gonna take. So let's go. And hello guys, we're back now on the another major topics of the chapter 7, the logical ending. It is somewhat in order to get the network address of the network and other stuff. Then let's read it. The logical end or logical end is one of the 3 basic binary operations used in digital logic. The other 2 are not and not, while all these are used in data networks only and is used in determining the network address. Therefore, our discussion here will be limited to the logical ending operation. Then logical end is a compromise of 2 bits that produce the result shown in figure 1, as you can see in here. Then note how 1 and 1 excuse me for that, produce A1. Then the simple operation for this is if 1 plus 1 and there's 2 ones, it will be 1. If there's a 0, they would be 0. It's just true or false, or if there's a false, there will be false. If true and true, it will true. False and false, it will be false, and false and true, it will be false. Just it has false and other stuff. Then as you can see in here, and the subnet mask, and as you can see 1 1, then 0 0 because of there's 0 and other stuff in here. So you can see the network address is 192.168.10.0. Then the yellow highlighted section in the figure 4 identifies the end bit that produces binary 1 in the end result row and some other stuff. So let's proceed. Then activity, as you can see here, there an activity called the ending. Then let's check. As first, we will know that the network address would be 10.10.1100. Then the other one would be 0.0.0.1.1.0.1.1, because we're just gonna check the host address because that will be the binary. That then it would be 0.1.0.0.1.1.0.0. Then after that would be all zeros. Then this would be 172.27, then 76, then 0. And let's check. As you can see, my answer is correct because it is somewhat just like how you will add the two binaries. And that's all for this activity. Then let's go to another one. And hello guys, this is just already one of the most or major part of the chapter 7, the unicast, multicast, and broadcast. It is just simple because unicast address, just like that, it will send a single packet to a single device. Then a broadcast address is, it will send a packet to all device, that all device will be sent, as you can see in here. Then the multicast packets is just a specific group of, as you can see, it will just send on the specific group, then only in these two laptops. Then that's all for the three, and it's just very basic. Then let's check if this activity can start 117. They find the 17, then this one, and as you can see in here, let's check the timer. So let's try. Then as you can see, I've successfully, then 1, reset again, then start. 05, let's check the 05. It is just a unicast address. Then as you can see, then it will all be, yeah. That's all for this activity. Then let's proceed to another topic. And guys, we're back. This one also the major topics in the chapter 7, and the connection of IPv4 and IPv6 coexistent. Then there are three things that you should always remember: the dual stack, tunneling, and the translation. By the way, the dual stack is somewhat just like this on the figure 1. Then it's somewhat just device run both on IPv4 and IPv6 protocols simultaneously. Then the tunneling would be transporting. Tunneling is somewhat just a method of transporting an IPv4 or IPv6 packet over an IPv4 network. Then the translation is somewhat using a NAT or network address translation to allow IPv6 enabled device to communicate with each other. Then after that would be, yeah, an activity. As you can see, 128-bit 340 on decillion, that would be IPv6. Then 32-bit address 4.3 billion, that would be IPv4. Then transport an IPv6 packet over an IPv4 network, that would be a tunneling. Then uses NAT, it would be translation. Then allows IPv4, then segments, it would be dual stack. Then as you can see, it is just pretty easy and other stuff. Then let's proceed to another activity. And also in this chapter 7, you should always know the compressed form or the omitting sorry for that, leading zeros. Then as you can see in here in the chapter, in this, if there's a 0 on the front, it would be cancelled, and other stuff. It would be 4 zeros, it would just be 1, then other stuff. Then let's proceed to rule 2. Hold that. Then rule 2 is omit all 0 segments. Then as you can see in here, if there are all zeros, that there would be just 0 or just 2 colons that you would do. Then as you can see in here, omit the leading zeros, that would be 211 zeros, BB8, then oh sorry for that, it would be 8, not BB. Then 111 plus 0 0 0 200. Plus then the compressed format would be 10 BB8 111, then zeros, then 200. Then as you can see, let's check. Oh, why? Oh, there's only something. Yeah, there are so many activities, but we are running out of time, and it's just very simple. So let's leave it that way, and let's proceed to another one. Then guys, I think this is the last activity for the or last tutorial for the chapter 7. Then as you can see in here, unique internet routable IPv6 address dynamic, that would be a global unicast. Then the FE80, if you see that would be a link local. Then another one would be a global unicast. As you can see in here, typical IPv6 prefix, that would be this one. Then used to communicate with other device on the same IPv6, that will be a link local. Then let's check. As you can see, all my answers are correct, and that's the preview of the chapter 7 tutorial.